Okay, moving on. Abhisar Bharti is with us, data science consultant at Machine Learning Reply. In this talk, Abhisar will introduce Prometheus and Grafana to do effective monitoring on infrastructure. We will also look into the Prometheus configuration in detail with optimization in mind and a small demo of a simple use case.
So, good morning, everyone. How are you feeling now on a scale of 1 to 10? I hope 10. 7 is also nice. Yeah, so as we have seen from yesterday, we had a talk about transfer learning. We talked about some new advancement in prediction, forecasting, and so on. And I think my talk completely sits next to it, because how I would tell you is basically you can build pretty cool algorithms, you can generate business value from it, but how would you ensure that the model that you have developed is going to give you constant business value? And there comes my talk, which tells you there are some ways through which you can do monitoring, which is like ML ops. I would also like to keep on switching machine learning operations and ML ops continuously so that you can follow. And why this is something which is really important in today's context, and why a lot of companies are actually investing a lot of money, their time, their research capabilities to come up with better solution in case of machine learning operations. Well, just to give you an agenda of today's talk, I will just introduce my organization from where I come from. I would also like to give you an overview of who I am as a person, because sometimes it's also important to know your speaker. And then we will directly move to our core topic of the presentation, which will be an introduction to monitoring and machine learning operation to the audience. And then we'll give you a small introduction of the tools that we have used. There are plenty, but I would just like to tell you about the ones that we have used in our use case. What will you achieve by using these tools in terms of MLOps? What are the advantage of using these tools, and at the same time, what are some of the challenges that you would face when you use these tools in general? I would also like to show you a little bit of demo, not demo, like more or less like a dummy dashboard that you can think of, because we have like the projects that we had worked were closely operated, and we cannot like show you the real data or what was the output. But I can give you a little bit of food for thought to think about, like when you try these tools, you could have similar things for your use case. And quickly we'll summarize the whole talk that we had seen today. Well, I come from Reply, which is a pretty well company in Europe itself. It's omnipresent all around the world. We are a consulting company. We deal with most of the technologies that you could think of. We always like to work mostly on the new emerging tech. You can think of it in terms of data engineering, machine learning, and pretty much everything that is hyped right now. And yes, the graph in itself is giving you an overview of we are growing exponentially in terms of revenue, in terms of people, in terms of projects that we are currently taking on. And we have a startup culture, because I think a lot of young people have this problem where they get into a pretty huge company, they are surrounded with a lot of bureaucracy, and they have a lot of cool things in their head, but they can't try to test them. And this is what we provide at Reply. We give you an opportunity, cool projects to work on and just try and test the knowledge that you have gained in the university in that regard. And yes, as I'm explaining this slide, I would also like to tell you that we are already in Croatia, so please feel free to check out. And I will also share the QR code in the end where you can look for the opportunities that we have at the moment. And yes, some of the cool projects that I had the chance to work with was with computer vision, and we were doing it for the agriculture industry. And this is like one of those. When it comes to defense sector, we have projects for predictive maintenance for a lot of machines. And yes, these are some of the examples in that regard. So what the motivation of these two slides is like, yes, please feel free to check out. Maybe you will find something. And yeah, during our coffee break, you can also reach out to me. I can also give you an overview of what I have done, and yes, what you can think of as a career with Reply. About myself, so I am a data science consultant at Machine Learning Reply, working for almost a year and a half now. I have master's in data science. I am a time series enthusiast, mostly dealing with predictive maintenance using time series analysis, and at the same time, outlier detection and anomaly detection for manufacturing industry in my previous projects. At the same time, I'm also a contributor of structured literature review. If any one of you has ever tried digital libraries, you know how painful it is to come up to the actual research paper that you have needed. And in that regard, from my university, I am actually working on building a semi-automated approach that helps you to find literature that you had actually started looking for in those digital libraries. If you really want to read my contribution, you can go to Elsevier and just type Abhisar, and you would find some of the research paper that I have published in making this whole process a bit better. I also like data storytelling because I think you can build pretty cool solution, but in the end, the output that you have generated is really important for the management to understand, and how you can connect those dot points to build up a story is really important when it comes to driving the business. And this is like one of the skills that I'm still learning and I'm continuously improving myself on. And yeah, on the right side, maybe it's a diagram that looks like as if a children has drawn, but yeah, this is something that I used to, like my drawing skills are still like that, and I wanted to just show you that there are some things in life that never improves. Yes, now moving towards the more important and core of our presentation, I would like to introduce you to monitoring and machine learning operations. This is like one of the slides that I prepared, and you can pull up any of those random articles, which will give you more of a feeling that why MLOps is so important and why lots and lots of big tech players are actually investing a lot of money in it. It is supposed that by 2028 or close to 2030, this whole industry is going to grow as much as 9 billion euros. And at the same time, a lot of companies, for example, Microsoft or Alteryx, those who know Alteryx, I don't know, but yes, they are literally trying to cut down the cost that is involved by doing effective MLOps by building solutions that are cheaper and at the same are made to scale. And yeah, this is just 3 articles that talks about it, but you would find plenty of resource that should give you enough motivation to think machine learning operation as a career in parallel to the normal development of machine learning models. Yeah, I also like to have questions so that it's not a monologue, but more or less like a dialogue in my presentation. So I would just like from the audience, if someone could explain what to them monitoring is in terms of software development life cycle. Anyone? 5, 4, 3, 2, 1. Let me explain it to you. So here you see, how I look at MLOps is basically a layered approach, where I have a platform where all my ML workflow works, and I would call the platform on top of my MLOps. So sorry, pardon me. My platform on which all my ML services are working. And what I would ask myself, if everything is working is fine or not, would be the first 3 questions, which will talk about if the platform is up or not. Because if the underlying platform is not operating, everything that I have developed on top of it is of no use to me. Then the third question would be, is it degraded? So yes, sometimes those from the software industry would know it, that you have a server which is actually running, but it is not capable to handle all the requests that it is receiving. And this state is more or less like a degraded state that I call. So everything seems to be working, but they are not working at its efficient fashion. And these 3 are basically the smallest question or the primitive question that I would ask when I look back to my infrastructure that runs my ML workflow. However, on the left side of this slide, you would actually see that how a typical ML workflow lifecycle would look like. You would start with the data that you have. Data is very difficult to find, and that's why whatever we have, which have true confidence, we use them to build a model. Yes, we do pre-process them to make sure that it is the data that my model accepts and can perform really well, and then we train our model. Once we train, we would like to evaluate them with certain parameters that we have. If you have trained a model, you know that you probably would build a confusion matrix, and this matrix gives you the confidence. So the value of this matrix gives you the confidence that it is something that I would like to deploy in production or not. And yes, once you have deployed it, it is also important to keep track of your model, because there are so many things that will change. The data that you had in the start was quite less, and how we in production tries to approach to this problem is like we constantly try to make predictions, and we feed this prediction back along with maybe a few more subset of data in that period of time has generated. So we combine them, we retrain our model, and we continue doing this process over and over again. But how about if there is no tracking? If there is literally no tracking, we are so confident that yes, what we have built is the best, and we don't want to monitor this. What can go wrong in this scenario? The behavior of data will change. You feed them back to your model, and now the model will start giving you bad predictions. Since there is no monitoring in place, you start taking business decisions with it, feeding the wrong data back again to the model, continuing this process over and over again, and you end up with the prediction or the output which is far from where you have actually started. And this is what gives you an overview of why, in general, it is important. Now, since we had already started this conversation with a two-layered approach, where the bottom layer was platform layer, and the top layer was your machine learning workflow layer. So each of these layers will have small subsets. And I would like to know, when it comes to monitoring my ML workflow, that the data that I am bringing for monitoring should have its own label. So the last 3 lines in the slides. We collect the data, we would try to label them so that when we analyze them based on how the behavior is, we know that from which subset this data is being brought to my system. Now, someone can also say that why is it really important for real-time monitoring? As I said in the previous, this is how an unregulated life cycle would actually look like. Because we have less amount of data, we are feeding it back, we are generating bad prediction. Bad prediction will lead to bad business decision. And since, once again, the input is what we had as a ground source or a ground truth that we call in machine learning, we are feeding that wrong ground truth back to the model and doing it over and over again unless we reach to a point that someone looks at all the prediction and says, hey, this is not what we had thought. We had completely different idea when we built this model, and now the prediction that we are generating is completely different to what we had actually aimed of. I hope that day never comes, because if that day has arrived, that means we are way far from where we have actually started. And yeah, this is one of the graphs that also shows that how a business value will degrade over time when there is no monitoring in place, and how it is still stays. So we are not living in an ideal world, so there will never be a linear graph. But it is something somewhere in between with a little bit of fluctuation, and you would see that a monitored model is always something, or a monitored architecture is something that is giving you the result which is still acceptable for a production use case. Once again, a question for all of you. Well, we looked at why we should do monitoring, what can go wrong when we don't do efficient monitoring, but let us take the same example that I had given, a very basic one. Let's say we have a client-server architecture where the server takes the requests and brings back the result that the client has asked for. Now, when I take this example of server, what do you think should be the metric that I should monitor? Anyone? Five, 4, 3, 2, 1. So the basic example of, let's take your own laptop, because I don't know if server is something for most of the audience, I don't know. So what do you have in your laptop? You have CPU, you have RAM, you have disk, and maybe you would also like to know if my laptop is on or has it already turned off. So these are the small metrics that I would like to monitor when it comes to my simple laptop use case. I would like to know maybe I'm not running a program that is so intensive that my CPU utilization is always 100%. Maybe I would like to know that my disks are not so filled up that is close to 100%, or a basic example which we call in software industry is like health check. I would like to know if my laptop is alive. Well, in case of server, you would like to know if it's alive or not. And yeah, you can do it with the help of endpoints, for example. And this is what I would like to show in the same way which I showed you, like 2 ways of the model thinking. Your first model is the operational model, so is the platform model that I had talked about. You would like to measure all of those things related to your platform, because this is what provides you the opportunity to run your ML workflow. So you would like to know if your model is, your platform is actually alive or not. How would you do it? You do it with basically the same example that I have given. You would like to check if there is a CPU throttle of the platform, like it is being like 99 to 100% for most of the time when you run heavy workload, for example. You would also like to check if the system uptimes are to the standard or not. For example, is it the case that during the heavy workload, your system restarts most of the time? So this is what we do at some point of time as well, because some of our workloads are so intensive that it gets our platform to have a frequent restart, which is not good in production. So you would like to have these kind of checks for yourself. And then we move towards the functional aspect of monitoring, where we will talk more about our model development. So if any one of you have ever tried building a machine learning model, you know what confusion metrics is, how you make sure that your model is sufficient enough to actually bring them into production. So you do some basic stuff. For example, you would like to see if the accuracy score is acceptable or not. For example, you have 99% of accuracy for the model that you have trained, and this is which is something which is acceptable to you. So you'll be like, yeah, if there is a sudden drop, so like over a period of time, the accuracy drops to 75%, no, I would not accept this model. So this is what you would like to track. At the same time, you would like to track error and everything else like precision, recall, and F1 score. At the same time, you also know that the behavior of data will change, because as the time will grow, new data points will appear, your new prediction will appear, which you feed back as the ground truth or confidence back to your model. These new data points may not be the assumption, so like may not be similar to the assumption that you have started. So maybe you had started with a distribution that you thought would be the one that will stay forever, but maybe adding this new data point has changed the distribution itself. So you would like to know 2 things maybe in general. So for example, how much the distribution has deviated over a period of time, which features are the one that are actually contributing for the whole data set deviation, and what is the general deviation for each of those features. And you would like to track them over time. You would like to make sure that there is a proper monitoring in place, which gives you proper alerts for the thresholds that you have set. And as soon as something changes to the limit that you have set, like far from the limit that you have set, you would like to take actions on them. Because if you don't take action over a period of time, the whole goal that you had set in the start will change in general. How would you do it? This is the third part. Like, what tools would you like to use? There are plenty of tools in the market that you can try. I am more towards using an open source technology because it gives you the flexibility to customize it. It gives you the flexibility to make it more towards your need. And I think you don't have to pay a lot of money unless you are not using a customized solution. What I would like to introduce you today is like 2 of the most widely popular tools that you can use to do an effective MLOps. And this is just the starting point. Given the time that we have, I cannot introduce you to all of that, but I would really like you to get these two names maybe back home, and if you find MLOps as a goal for yourself or a career in this direction, I think these two tools will be a perfect starting point. Well, if you look into this diagram, this is the similar way of like feeding the data to your ML system and then starting the MLOps part, where you would like to monitor. So all the metrics that we have seen so far will be exposed using ML system. And Prometheus, which is an open source tool for monitoring, I really like it just because it gives you more of the flexibility of working it in an operational setup. So for example, one of the things that Prometheus provides is using for dynamic orchestration. So you can apply new config without the need to restart. So like it gets applied directly and you don't need this abrupt stoppage in your normal working environment. At the same time, how Prometheus works is basically you need to install these exporters. There are plenty of exporters to get different kinds of metrics. It also gives you the opportunity, if you have the skill set in your team, to write your own exporters that exposes similar kind of metrics that you want to export. You can also write your own metrics using Prometheus in any query language that you want to write. At the same time, you expose these endpoints for all the metrics. And what Prometheus does is a pull-based approach, so it goes to all of those endpoints and brings the metrics that you have exposed by writing a scrape job, which has the endpoints written in it. So it looks for all those endpoints, look for all the metrics that you have exposed, and then take it back to Prometheus. Prometheus is a time series database, which has the appending data feature. So it gives the history of mostly 15 days, so like 2 weeks of data for a particular metrics. And you can actually visualize your data in Prometheus as well, but I would suggest that you use Grafana, which is for more advanced data visualization. I think Prometheus and Grafana probably are the match made in heaven because they are like really well combined. They have like lots and lots of features to actually work on. You can build really well intuitive dashboards. You can set thresholds, you can set alerts, and then can monitor. And it also helps you to go more towards the observability part of MLOps. So not just to know what's wrong, you could also take some next steps in trying to fixing it, maybe using Grafana Loki, if you have heard of this tool's name. And yes, another thing, who doesn't like free stuff? So with Grafana, the community is so strong that you have a lot of pre-built dashboards that is more or less like plug and play. So if you know what the need is, you can actually look for one of those dashboards, bring it to your environment, plug your data from Prometheus, and voila, you have a pretty well-built dashboard that you can work with. And at the same time, the learning curve is also not that steep. You can start by building a small dashboard, maybe with few panels, maybe with few alerts, and you can keep on improving over a period of time. And I don't know, maybe from 3 to 6 months, you are well and good enough to build your own MLOps dashboard and do effective monitoring in that regard. However, well, it's a free stuff, so it has its own challenges. The most important problem that we have seen so far, at least I have seen this problem in 2 of our projects with healthcare and insurance industry, is that Prometheus, by default, exposes huge amount of metrics. And maybe 100 megabyte doesn't sound a lot to you, but in terms of metrics, that's a huge amount. And if you are scraping every 5 minutes, 100 megabytes of metric information over a period of time, this amount is like quite huge, and which is not good. And yeah, as you see in the diagram itself, there is a period where you do not see anything. And this is called more or less like a data gap. And since you are consuming this in one of your dashboard, maybe this metric in one of your dashboard, for that time period, you will not have any information there. That means that if you have set alerts where there is no data, you will start receiving lots and lots of alerts, and that might create panic if that is the metric that is very important for you. So we have to make sure that we are not bringing too much of data. We should always somehow follow this least privilege principle in terms of metric, that we make sure that we only bring the information that is being consumed in our one of dashboards, and not like by default, if it is exposing hundreds of metrics, we are just bringing all 100 of those metrics. Like, that is not a good way to tackle this problem. And yes, if you are bringing a lot of data, you will have the higher scrape intervals, which is also not scrape time, which is also not good in this regard. How you can solve this problem? Well, there are plenty of ways through which you can solve this problem, but I would like to just give you an overview of 3 or 4 ways that we have tried, and maybe in your use case, you can also give it a try. The first and the foremost part would be to actually identifying all the metrics that you don't need in your environment. And as soon as you know all of those, the config of Prometheus is so intuitive that there is one feature called Prometheus Relabel config, where you can list all the metrics that you don't want. And you put regex, so regular expression, and then you put an action as drop, and while the next time the configuration is load, it will still scrape all of those metrics, but wouldn't bring anything to the database. So it wouldn't bring anything to the time series database. This actually helps a lot, because it tries to reduce the amount of metric that you are collecting, and also gives you a sense of feeling, if you are documenting it somewhere, that they are the things that you don't want. And maybe in future, maybe there is one metric that you want to bring them back. You just remove them from this configuration, and it is still back there. The second thing that we would like to do, or I would think would be the most important part, would be to play with the scrape interval. Maybe you do not have a data which is so time sensitive that you need every 1 minute, or maybe every 30 seconds. So doing more of a frequent scrape will result in a lot of information, but it could be also something that you really don't want. So playing with the scrape interval time to come up with the exact scrape frequency would be the next thing to do. And at the same time, let's say you tried all of this and you still have so much of information that you really want to bring, and you have like no escape. At that time, I would say that would be the last thing that you should do, is basically to use managed service. You can use any of the cloud provider, as far as I know. So you can use, at least that I know, is you have AWS managed Prometheus, and at the same time, you also have Microsoft Azure managed Prometheus. What I have used is AWS managed, and yes, it was something that still takes away a lot of this hassle, but at the same time, I think, yeah, managed services are actually good, but it should be our responsibility as a developer to actually make sure that we do not bring the data that we don't need in our environment. In the end, when you have this pipeline actually configured, where you are taking your data back from all of these services, you still have a dashboard which would actually look something like this. And then you can do all those monitoring using this dashboard, and have an overview related to that. Oops. It's not moving. If you can move it from there, that would also be fine. Yes. Finally, look into the challenges. Yes, diverse stakeholder, diverse need. So this is something that you have to take care of. At the same time, you need to make sure that you have the team that is capable of actually making sure that if there is a metric that is not being used in any of those exporters, they are capable to write those exporters by themselves. At the same time, as I always say in most of my presentation, we should make sure that we follow ethics of AI, and not bring the data that we shouldn't bring to this system. So like monitoring is actually something that you should do for your system and not on for any of those confidential information. And yes, if Prometheus is not being optimized, it can generate a lot of problem for you in future. So a recommendation from my side would be to actually spend 80% of your time in building a right configuration and maybe 20% of your time in actually deploying these services. Finally, the summary. Yes, we looked into what monitoring is, how you should do monitoring, what can go wrong if you don't do an effective monitoring. I also show you a sample of dashboard. We also saw what are some of those metrics that you would like to monitor in Prometheus, what can go wrong if you do not have a great Prometheus config prepared in a production setup, how you can tackle that, and finally, we had a small look at the dashboard, dummy dashboard that I had prepared. Oops, right on time.